This lesson, we're going through one of the topics that is the most satisfying to do when done correctly, of course, which is algebraic proof. Now, the learning objective today is to know how to write expressions for various algebraic terminologies. We're going to apply these expressions in algebraic proof question, and obviously we want to prove them successfully. Now, before we dive into terminologies, we have to understand why there are difference of using there are difference of terminologies in there. First of all, even numbers is like having ID, okay, on the person. So how do you prove you are an even number? Okay, in the algebraic world, citizen, imagine there's a world only algebra walks everywhere. How do you prove you are an even number? Okay, so on your ID, you will have a 2n on there.
Show me your ID right now. Bruh.
If you don't want to use n, feel free to use any other algebra, any other letter. But in proof, we tend to like to use n because, in math, sometimes there are different letters used for different things. Nth term, we usually like to use n. N represent terms, so therefore we use n in here. Odd numbers, you can use 2n plus 1 or 2n minus 1. Not being racist in here, but I do prefer 2n plus 1 more than 2n minus 1. Reason being is having a plus in there makes it a lot easier and less algebraic prone, less silly mistakes basically. Consecutive numbers, if you're next to each other, the first one will be n, n plus 1, n plus 2, n plus 3, etc.
That is scary.
Again, you can use n minus 1, n minus 2, n minus 3, but I would tend to avoid negative if all possible. Next one, consecutive even numbers. So if the first even is 2n, the next one will be 2n plus 2, and then plus 4, plus 6, etc. Consecutive odd number, the first one is 2n plus 1, so every time we add 2, so it'll be 2n plus 3, 2n plus 5, 2n plus 7, okay? To prove you're a multiple of 5, you do want to factorize a 5 outside bracket. So your final answer should look like this line, 5 and then a bracket. Now, even though you can factorize maybe something else inside bracket, you do not need to factorize it. All you need is the 5 and then a bracket. A multiple of 8, 8 and a bracket. When it says always even, which is the same as saying it's a multiple of 2. So you just have to pull out a 2. Okay, so even means a 2. If we say two different even numbers, then we will have to say 2n and 2m. We can't use the same letter. Okay, I'll explain more actually later in the example when we talk about different numbers, even numbers. I'll explain why we can't use the same one. Two different odd numbers, again 2n plus 1 and 2m plus 1. You must use two different letters. One slightly easier version of the question is when it asks you show that, and then you see a triple equal sign. This means equivalent. So what does equivalent means? What's the difference between triple equal and double equal? A double equal means the x is not always valid. Okay, so equal means it could be equal, but it's not always equal. For example, x plus 7 equals 10. For this to be valid, x must be 3. Anything else wouldn't be valid, right? Because if x is 4, it wouldn't work. However, if I say equivalent, maybe like x plus x is equivalent to 2x, then this must be true because whatever x value you put in there, it will always work. So that's the difference if you're interested. The main thing here is if it's a show that question with equivalent, you will have to either start from left hand side or the right hand side. We'll go through the first example using seeing this type of question. First example, show that x plus 5 squared minus 7 is equivalent to x squared plus 10x plus 18. These type of questions usually are not difficult is because they're usually quite straightforward. They tell you what to do. Well, you have to start from the left hand side or the right hand side. Now the right hand side, there's not much we can do. So we're going to start with left hand side because in left hand side, we see a bracket, we see a squared, expand the bracket. So the structure is we start from left hand side. Okay, so I'm going to write left hand side. I'm going to rewrite the left hand side once. It means this is the only thing I can work with. I'm trying to work towards the right hand side. Okay, so in here what I can do is I can expand the bracket. So I'm just going to rewrite double bracket. Expand the bracket in here, x squared plus 5x plus 5x plus 25 minus 7. So x squared collect the like terms and which equal right. So that's the same as the right hand side. To finish off the proof, we say equals the right hand side. So we have shown the way we work from left hand side towards the right hand side. Okay, you can start from right hand side. If you do want to start from right hand side, can you guess what can we do if we want to start from right hand side? We can complete the square. If we complete the square, we get x plus 5 squared minus 25 plus 18. So we complete a square on the x squared plus 10x. And then minus 25, oops, sorry. Minus 25 plus 18 is the same as minus 7, which is same as the left-hand side. So that works, okay? I would say the left-hand side, starting from the left-hand side is definitely a lot easier than the right-hand side, okay? Here is practice question 1, okay? It's a show that question equivalent. So you either start from the left-hand side or the right-hand side and show all the way to the other side, okay? Try to keep the structure like the previous, like what I did, and then have a go at the question. Pause the video. When you're ready for the answer, you can press play. Here are the answers for question 1. I'm not going to go through it because it should be fairly straightforward, I guess, for question A and question B. Next, we are going to go through a few examples of different types of proof. The first one we're going to go through is the multiple of something, and then divisible by something, odd and even, and then you do some practice. Right, so the first type, about multiple of something. Now, with these type of examples, they usually write the questions usually in words. So what you do want to do is you want to highlight or underline some keywords that is useful for you to construct your proof. So prove that the product, okay, product is a keyword because it tells you how to join up the terms of two consecutive even numbers. It's a multiple of 4. Right. So first of all, let's do it one by one. Multiple of 4 means our final answer, okay, our final line should be 4 times something. Okay, I've mentioned it in notes before. Multiple of something means 4 times something. All right. Next one, a product means you have to multiply. Okay, I don't want to put a cross because it looks like a cross. So I'm going to put a multiply. A cross looks like a cross. Sorry. Right, multiply. Two consecutive even numbers. So even numbers means 2n. Consecutive means 2n plus 2. So what we want to do is we want to multiply these two terms together. So 2n times 2n plus 2. That's what the question wants. So expand the bracket. 2n times 2n is 4n squared. 2n times 2 is 4n. We want to have a final line as 4 times something. Now, as I said, it doesn't matter what's inside the bracket as long as we can factorize a 4. Now, obviously, inside bracket, we can't have fractions decimals because that means we can't factorize it completely. But in here, you can see we can factorize a 4 quite easily, and therefore, it is a multiple of 4. To be honest, the last line is not really required. If you finish up to this line, and that's usually correct. Okay, so as long as you can finish up to this line, that will be fine. Okay, so factorize a 4 times something, multiple of 4. Prove that the sum of 3, so sum 3 consecutive numbers is divisible by 3. Divisible by 3 is the same as a multiple of 3. So don't get tricked by the wording. It's the same thing. Multiple of 3. 3 times something. Okay. Sum of 3. Sum means add. You can add them up together. Consecutive numbers. So n plus 1, and n plus 2. We talk about the consecutive numbers again in the notes. If you have a look in the terminology part of it, consecutive numbers n plus 1, n plus 2, n plus 3. Right, so we're going to add them up. So n plus n plus 1 plus n plus 2, which equals, to collect the like terms, is 3n plus 3. Multiple of 3 means our final line has to be 3 times something. We can do that. 3 bracket 3 n plus 1, and that's the answer. You have shown that. You can write it's a multiple of 3 or it's divisible by 3, but it doesn't matter. Next example is an interesting one because we have to prove a sum of an odd number and an even number is always odd. So naturally, when we say odd number, we use 2n plus 1. Oops, sorry. We use 2n plus 1 for odd number, and for even number, we use 2n. Now, but there's a reason we can't use both n's. Now, when you think about What's the relationship between 2n plus 1 and 2n? By making a 2n and 2n plus 1, it means they are consecutive. So if we do make them as 2n plus 1 is 2n, they're consecutive, because if the first number is 2n, add 1 to that number will be the next number, so consecutive. But the question did not say about anything about consecutive, so you cannot force a relationship in them. It's like you are grabbing two random strangers and ask them, yeah, be friends, put them together.
We are not friends.
But you can't do that, right? So that's the same thing in here. We can't make them be friends, and we can't force a relationship on them. We can't force them to be consecutive. So the way out is to make one of them into m. So we're going to use it as 2m. So once we use a different letter, it means we break their relationship. They're no longer consecutive. This is an even number. This is an odd number. Okay, so what we have to do is to do sum, so add. Now you'll be wondering, how do we show odd number? So, well, keep listening. So first of all, add them up. So 2m plus 1 plus the 2m. Next, to show us an odd number. Now, one thing, what do you realize about odd numbers? Have a compare even numbers, odd numbers. What's the difference? The difference is 2 times something, and then you have plus or minus 1. So you're adding 1 or subtracting 1. So what you want to do in here is the same thing in here. You do want to factorize 2 out into 2 times. So what I'm going to do first is I'm going to put these 2 times together, 2 and a 2m, because they both have a 2 in the front. So I'll first write 2n plus 2m plus 1. So what I did in here is I rearranged the terms. So you can see 2n and 2m is now in the front. Next, I factorize the 2 out. So 2 bracket n plus m plus 1. Now, for this one, you do have to write a bit of explanation. You can't just like this. Even though we have finished our proof, but we have to write a final answer to actually finish a proof, to explain to dummies why it's odd. Now, 2 times something is always even, right? So 2 times something is always even. When you have, therefore, so it implies even plus 1 is odd. So therefore, 2 times n plus m plus 1 is always odd. And that's the end of proof. You must write these final 3 lines to show it's odd and even. So to show something is odd and even, you do have to have a bit more. Even is easy, because to show it's even is the same as 2 times something is a multiple of 2. But to show it is an odd number, you must say even plus 1 is odd. So that's a key line. Practice question. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Here's the answer. Quite straightforward. 2 consecutive odd numbers, 2n plus 1, 2n plus 3. Sum means add them up. Even, factorize the 2 out. And there you go. Here is question 3, practice question 3. Pause the video again. Have a go at the question. When you're ready for the answer, you can press play. Here is the answer. I did tell you, did warn you, I did give you a tip to remind you, do not forget the brackets in here.
You have one new message.
Don't forget me, I beg.
Okay, once you've got that right, change the sign, everything, you should be able to factorize the 8 out, as they said, in a multiple of 8. Hang in there, 2 more questions, you can do it. Have a go at practice question 4. Okay, when you're ready for the answer, you can press play. Here is the answer. I don't see this question being very difficult unless you got it mixed up with the beginning of how to write the 3 consecutive even numbers. So with this type of question, the main thing is to learn how to write terminologies correctly using the table in here. If you remember this table quite well and you can use it quite well, I don't see a problem of these type of question for you. Okay. Now, I deliberately put the last one a bit of a challenge. See if you are able to try crack it out yourself. Have a go at the question, pause the video. When you're ready for the answer, you can press play. First of all, to show it's a square number means something squared. Like for example, 81 is a square number because it equals to 9 squared, right? 100 is a square number because it equals to 10 squared. So something squared is called a square number. So what you want to do is to prove the sum of it. Sum means you want to add these two terms together, these two terms. Now that's one term because they're multiplied. That's the second term. So you want to add them up, but before you add them up, you have to multiply, expand the bracket into n squared minus n minus 12. And then when you add the 3n plus 13, you should be able to simplify into n squared plus 2n plus 1 and factorize it. You get n plus 1 whole thing squared. That's a square number.